This video is on modular functions, and it's about how to make the modular function from the graph. Well, the first thing to remember about modular functions is that they're effectively the function of a line that's been reflected back up off the x-axis. So when we go to make the function, we can begin to make it in quite a similar way to the way that we could make the equation of a line. We'll just have to modify it a little bit at the end to make it correct for a modular function. The first thing that we should do is make a note of the x and y intercepts. In this case, those are minus 2, 0 and 0, 2. I can use these 2 points to get a slope. Now, obviously, since I'm going to use minus 2, 0 and 0, 2 to get a slope, that'll be the slope of this portion of the modular function. And my slope comes out as 1. Don't forget that I can call slope m. I'm now going to use this m, the slope, along with the y-intercept to make the equation of a line. The equation that I'm going to make, using the formula y equals mx plus c, will in this case be 1x plus 2. And that's from looking at, like I said, the m value, my slope, and my y-intercept. So this is what I would do if I was just making the standard equation of a line. And what I've really done here is found the equation of this yellow line. So it's the line that would be created if I was to continue on down from my y-intercept through my x-intercept and keep going as a line. But I know that it's a modular function, so I never end up in the negative region of the graph. Once I get to the x-axis, I bounce up to stay in the positive region. So to adjust this function, to make it be the modular function, I just need to make sure that it always stays positive. I'm going to call the modular function, in this case, f of x. And this is f of x. It's just the absolute value of 1x plus 2. Okay, so let's have a look at a second example. I'm going to call this one g of x, and I want to find its equation. So like before, I'm going to note the x and y intercepts, and I'm going to use these to get the slope. And in this case, it comes out as negative 1/2. I'm not surprised, because if I look at the line that joins up the x and y intercepts, I can see that it's sloping downwards. And I'm just going to note what the y-intercept was. So we went through the y-axis at 2. So if I was just making the equation of this line then, it would be y equals to minus 1/2 x plus 2. But it's not just a line that I have, it's a modular function. So it doesn't continue on in a straight line once it gets to the x-intercept. It bounces back up to stay in the positive region. So remember, all I have to do is put the absolute value lines around the equation of this line, and that then gives me the modular functions equation. So in this case, I could write g of x as the absolute value of minus 1/2 x plus 2. One last thing to note with this particular example, there is actually an alternative way that I could present this final modular function. I could write this g of x as the absolute value of 1/2 x minus 2, and it would actually come out to be the same thing. You'll see that the only difference between these two versions of g of x is that I've changed both the signs. And so it's possible to write it as minus 1/2 x plus 2 between absolute value lines, or the absolute value of 1/2 x minus 2. And both are correct.